Hello everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying trigonometry lecture 2. Basically we'll be studying about light angles in this lecture. Now there is one more announcement I wanted to make before going forward. Actually, according to the given schedule, I have kept 3 lectures for trigonometry, but I don't think that would be sufficient to complete the entire syllabus of trigonometry. So I'll be taking 5 lectures on trigonometry before starting other topics. So let's now directly jump into the discussion of trigonometry lecture 2. So this is our question 5 of the quick QOD series. Just have a look at that, take a screenshot of it, and we'll proceed forward. So what are allied angles? Allied angles are those angles whose sum or difference is equals to 0 or it's a multiple of 90. Right? So for example, 60-30, 120-30, or let's say 225 and 45. In this case, summation is 90, right? In this case, subtraction is 90. In this case, subtraction is 180 and summation is 270, right? So in this case, both summation and subtraction would yield allied angles, right? Now let's look at case number 1, 90 minus theta and theta. So in every case, there is one assumption. That assumption is theta is acute angle. So here theta is acute angle. Even in the other cases where we are going to second or third quadrant, theta is always going to be acute, right? Now we'll do a simple construction for this. These are perpendiculars. Let's call it as O, this is A, let's say this is B and this is C. Now based on our previous understanding, we can clearly see that sine theta is nothing but AB by OA and cos theta equals to OB by OA, right? Now, since this is a right angle triangle, OAB is a right angle triangle, so this angle is 90 minus theta. So let's try to write sine of 90 minus theta. So in case of 90 minus theta, OB is perpendicular, AB is base, and OA is the hypotenuse. So in this case, sine of 90 minus theta is nothing but OB by OA, which is nothing but cos theta, right? Similarly, we'll get cos of 90 minus theta as sine theta. You can do the derivation part. Now here you don't have to worry about the sign convention, right? Because everything is in the first quadrant. Theta is acute. In that case, all the trigonometric signs are positive. We have already seen that, right? Let's move to the other case, which is 90 plus theta and theta. This is also an allied angle. Some difference of this is 90. So this is also allied angle. So this is our theta. Let's say I want to make 90 plus theta. In that case, this is 90 degree, right? This is 90 degree. And we'll have to make additional angle theta over here. I'm doing the constructions by dropping perpendiculars from this point. So let's say this is O, this is A, this is B, this is C, D, E, and F, right? Now we can see that in triangle OAB is congruent to triangle ODE. Triangle ODE. How? AAS property. We have this angle common. This angle common. We have this angle and this angle as equal. This angle and this angle is equal, and this radius as equal, right? So AAS property, based on AAS triangular property, these two triangles are congruent. Now why am I doing this? So let's write sine of 90 plus theta. According to our basic definition of projections, sine of 90 plus theta would be projection of radius on y-axis, which is nothing but OE, divided by the radius itself, OD. Now this is nothing but, if we apply the congruency over here, OE is nothing but equals to OB, and OD equals to this, OD equals to OA. And if we talk about the triangle OAB, what do we get over here? We get cos theta, right? This is base upon hypotenuse. So this is nothing but cos of theta. So again, we get the similar kind of result as earlier one. In that case, sine of 90 minus theta was equals to cos theta. Here as well, sine of 90 plus theta equals to cos theta. Now let's look at the second derivation of cos 90 plus theta. That is more interesting. Let's write cos of 90 plus theta. Now based on our circular system definition, cos of 90 plus theta is nothing but projection of OD on x-axis, negative x-axis, which is OF. We'll introduce minus sign over here because it's on negative side, right? OF divided by OD, right? Now we know that OF equals to DE. So this is nothing but minus of DE by OD. Now these two triangles are congruent as we have proved earlier. So DE is nothing but AB, right? So this is minus AB upon OD is equals to OA. So this comes out to be a minus of AB upon OA, which is nothing but minus of sine theta, right? So now this is interesting that we are getting a negative sign over here. In case of sine of 90 plus theta, we didn't get a negative sign, but in case of cos of 90 plus theta, we got a negative sign. Now let's look at the other case of 180 minus theta. Now how to draw 180 minus theta? Let's say this is our angle theta. So this entire angle is 180. So if I subtract theta from here, so this angle, this particular angle would be 180 minus theta, right? Yes. So I'm not plotting it over here because it might create confusion. So you got the idea about it. So basically both of these rays are at angle theta from the horizontal line. Let's say this is O, this is A, this is B, and this is C, this is D, and this is E, right? Now let's try to write cos of 180 plus theta, 180 minus theta. Now according to our definition, cos of 180 minus theta is nothing but projection on x-axis divided by projection divided by the radius. So this is EO upon OD, right? Now we can clearly see that OD is radius, OA is radius, both are equal. These angles are equal, and this is also 90 degree. So again, by the AAS property, triangle DEO is congruent to triangle ABO, right? So I'll write it over here. Triangle DEO is congruent to triangle ABO, right? Now EO is nothing but BO, right? BO by OD is nothing but OA according to congruency. I missed one point over here that this projection is on negative x-axis. So we'll have a minus sign over here as well. Okay. Now BO upon OA is nothing but, this is cos theta, right? So it becomes minus of cos theta. So we have got cos of 180 minus theta as minus cos theta. Now let's look at sine of 180 minus theta. We'll get to know why I'm doing this. So again, let's look at this triangle. According to a circular system, sine of 180 minus theta is nothing but projection of OD on y-axis. So in that case, that would be OC upon radius, that is OD. Now OC is equals to DE, right? So that becomes DE upon OD. Now according to our congruency, DE is nothing but AB. So this becomes AB, and OD is nothing but OA. So basically we have got sine of theta, right? So we can see that sine of 180 minus theta is equals to sine theta. Now moving on to the other case. Actually, this is case 3. Now let's do similar kind of construction. So let's say this is angle theta. Now I have to plot 180 plus theta. In that, initially in 180 minus theta, what I did, I just subtracted theta from here. But here I have to add it. So this is 180 and plus theta. So basically these two becomes vertically opposite angles. These are perpendiculars. O, A, B and C, and D, E and F, right? Now let's quickly write sine of 180 plus theta. Sine of 180 plus theta is this angle, this bigger angle. So that would be projection on y-axis, that would be OF, on radius, that would be OE, right? Now since this is on negative y-axis, so we'll have one negative sign over here. Now I'll assume that you understand the congruency part. So OF equals to OB, right? And this OE equals to OA. So what we got over here, we got minus of sine theta. Similarly for cos of 180 plus theta, that would be projection on x-axis. Again, this is a negative x-axis. So I'll take a minus sign over here. That would become OD upon radius, that is OE. This is nothing but OD is same as OB and OE is same as OA. So that becomes minus of cos theta, right? Now I think you all have got decent understanding on how these allied angles are being derived, right? Now let's make certain general conclusions about these allied angles, because you might not be able to remember all these formulas. There are 4 quadrants, and with every quadrant there are 2 cases attached. So you might not be able to manually remember these formulas unless rigorously practiced. So we have a shortcut over here. So let's consider this case, sine of 90 minus theta equals to cos theta. So we see that this trigonometric ratio is getting changed. In case of sine of 270 minus theta, we will also see that this ratio will change. So we get a conclusion that whenever this allied angle is an odd multiple of 90, in that case the trigonometric ratios are getting changed, right? This is our first point. In case of even multiple of 90, so we saw that sine of 180 minus theta equals to sine theta. So we saw that this is an even multiple of 90. So our trigonometric ratio is not getting changed. In case of odd multiple, our ratio is getting changed. So this is the first concept to remember. Whenever an odd multiple is there, ratio is changing. Whenever an even multiple is there, ratio is not changing. So this is one thing. Now let's look at the last point. Sine of the final outcome is dependent on the quadrant of original angle and the original trigonometric ratio. So what does it mean? Let's say we have sine of 180 minus theta, right? So initially I have told that this angle we have assumed to be acute. So basically when we are writing this, we are assuming that this theta is acute. We have derived the formulas based on this only, right? Now this entire angle becomes what? It becomes obtuse, right? It is, since this is acute, so this entire angle will be more than 90 but less than 180. So it's in second quadrant. Now in the second quadrant, the original ratio is positive, right? We know that sine is positive in second quadrant, tan is positive in third quadrant, cos is positive in fourth quadrant. So the original ratio is positive. And since this is even multiple of 90, so in that case, our sign will remain the same, and it will become plus sine theta, right? Let's look at other example. Now let's say we have cos of 270 minus theta. So in the initial derivation, we have assumed that theta is acute. So basically this angle is in third quadrant, right? Now in case of third quadrant, cos is negative, only tan is positive. So we'll have a negative sign over here. And since this is an odd multiple of 90, in that case, we'll change the sign, change the ratio. So this will become minus sine theta. So this is the shortcut to find the allied angles. So you just have to remember this process and you'll find the entire series of allied angles, right? You don't have to do the derivation every single time. Now, these are certain important results based on the previous derivations. Sine of minus theta is nothing but minus sine theta, because minus theta is in the fourth quadrant. So you can do the derivation based on previous results. So this is minus sine theta. This is in fourth quadrant. Minus theta is in fourth quadrant. So we have minus sign over here. And since because here 0 is there, 0 is an even multiple of 90. So sign is not changing, right? Similarly, you can get that this is cos theta and this is minus tan theta. Also, when we are doing something like that, 2 pi plus theta or 4 pi plus theta or 6 pi plus theta, basically a complete circle plus theta. So that is nothing but theta only, right? Because we are doing one complete circle and again going theta over here. So that is nothing but theta. So this is very obvious. This is sine theta, this is cos theta, and this is tan theta. Now let's look at one illustration. So this says sine of minus 420 degree, cos of 390. I'll write it over here. Sine of minus 420, cos of 390, plus cos of minus 660 and sine of 330. Right. So what we'll do, we'll pull out the minus sign from here. So this becomes minus of sine theta, which is 420. I'll write 420 as 360 plus 60, right? Dot cos of, this is nothing but 360 plus 30, right? Now this becomes, we know that cos of minus theta is nothing but cos theta. So this becomes cos of, I'll write it as 720 minus 60, right? Dot sine of 360 minus 60. Sorry, 360 minus 30. Now over here, just to avoid confusion, I'll write it as 2 pi plus 2 pi minus 60, right? So I'll skip 1 2 pi. That becomes 360 minus 60, just to avoid confusion for the starting purpose. Now this is nothing but minus of sine 60, because sine of 2 pi plus theta is sine theta, dot cos of 2 pi plus 30, that is again cos 30, plus cos of 2 pi minus 60. Now let's use the shortcut. So we know that this is even multiple, so our sign will remain same. And we also know that this is in fourth quadrant. In fourth quadrant, cos is always positive, so that becomes cos 60, right? Dot, let's use that formula over here as well. So we know that this is even multiple, so sign will, this ratio will remain same. And 2 pi minus theta, so basically this is in fourth quadrant. In that case, sign is negative, so sign will change. This becomes sine of 30, right? So what we have got over here, let's take the minus sign common. So this is nothing but root 3 by 2, cos 30 again is root 3 by 2, plus this is cos 60, cos 60 is nothing but 1 by 2, and sine 30 is also 1 by 2. So what we have got, this is 3 by 4 and this is 1 by 4, so minus 1, right? So B option is correct. Now let's look at another example. Now I can see some kind of pairing over here. If I add pi by 16 and 7 pi by 16, so I get pi by 2. So that is a favorable thing. So what I'll try to do is I'll write it as cos square pi by 16, and I'll club it with cos square. I'll try to write it as pi by 2 minus pi by 16, right? That is also 7 pi by 16. So I can see that this is nothing but cos square pi by 16 plus sine square pi by 16. And we all know that this is a standard identity, which is nothing but 1. So one pairing is this and one pairing is this. So 1 plus 1, that is 2. D is the correct option. Now these are the type of questions you can get in the examination. So these are actually very simple problems, but in examination you might get a moderate or difficult version where you have to apply multiple concepts, maybe of compound angles or right angles. But this is just to give an illustration of how these kind of questions can be solved, right? So today's lecture was till here only, and I hope you are enjoying this series. So I'll repeat the announcement once again. We are going to add 2 more lectures for trigonometry because we might not be able to complete the entire syllabus in just 3 lectures. So we'll have 5 lectures for trigonometry. So let's meet tomorrow for lecture number 3. Thanks for watching.